Okay, Google, turn on board.
Okay, turning on the board.
You don't have to be bored in math class!
Thank you. Next. Thank you. Next. I think that's how it goes. You're probably here because you were just at another one. And you want to see another one of solving these trig equations. Oh boy, this stuff previously in math class. This stuff, oh, so new, so new. Ooh, who knew that the cosecant, yeah, that's 1 over the sine of 3x. Yeah. We're solving trig equations. We isolate. I guess I could have taken the inverse cosecant of both sides and that would have been fine, except you're probably not super comfortable with that. I'm not super comfortable with. So then this is the sine of 3x is equal to 4. I reciprocate. I give back to that problem and then I inverse sine. So that's that 3x is equal to the sine inverse of 4, sure. And then you check with blue face, baby. Sine inverse of 4. Domain error! Yeah, keep that out of there. This one is no solution. And if I can't do it, homie, it can't be done. Yeah. No, right. So, something more fantastical. I isolate the cosine, then I take the inverse cosine of both sides, and when I do, I'm gonna have that 2x plus pi over 4, sure. That's the cosine inverse of root 2 over 2. Previously in math class. Yeah, all right, so that's that 2x plus pi over 4. That's gonna be. Now, who's there? That's the pi over 4. Sure. Why? Because it's a root 2 over 2. So it happens here and it happens there. That's a pi over 4. That's a 7 pi's over 4. Sure. All right. So it's at both those places. 7 pi's over 4. And then I add the 2k pi to it. And then I add the 2k pi to it. So I'm trying to solve this for all of them. Then I'm going to find the ones that satisfy our given conditions. So I'm going to subtract that because now it's like solving a linear in 2 different cases. I subtract that 4 pi. I subtract that pi over 4. Sure. So I subtract that pi over 4. And I subtract that pi over 4. Why don't I do it to the 2k also? Only one. There can only be one. If you had 2 plus 3 plus 4, so the 2 adds to the 3 or the 2 adds to the 4, but it only does 1, and so that's the... Okay, let's go. All right, so that's a 2x is equal to, wait for it, pi over 4. That's just going to be 2k pi. All right, and then, 7 pi's over 4 minus a pi over 4, that's 6 pi's over 4 plus 2k pi plus 2k pi. All right. Now I'm going to go and I'm going to divide everything by 2. And when I say everything, I mean everything. So that by 2, that by 2, that by 2, that by 2, that by 2. Wait a minute. How come here you do that one too? Because it's multiplication and division. Okay. Yeah. The addition should go to 1. Look, Linda, look. If you had 2x plus 2, what do? Oh, look. There and there. It goes to both of them. Can you even see? No, you can't. You can see that. Look at it. Look at it. Okay, so now there's your x. And that's going to be, wait for it. That's k pi plus. Why is there a k there? There shouldn't be. Call it 0. Yeah, sure. Why? Because the pi over 4 and the pi over 4 just left the 2k. I guess I could have erased that one. That was the redundant one. Should I go on? Should I repeat myself? Is it a duplicate case? Oh, any case. That's that k pi. All right. And then this one, this is 6 pi's over 8. Yeah, 6 pi's is way overeating, but that is 3/4. Sure, 3/4 pi. and then this is plus a k pi. But I'm looking for all of the solutions in there. So when k is equal to 0, my x, let's look, 0. Oh, chalk. We're trying a new thing. My wife bought me some butter chalk because we've been in like isolation, and she did anything to feel better. All right, so nothing, and then 3 pi's over 4. That's written weird. You're written weird. Okay, and then that's pi, and then plus 4, 7 pi's over 4. Sure. So 4 answers. What incarnation? Okay, Google, turn off board.